The ancients knew the night sky intimately, but with the advent of artificial lighting and the growth of towns and cities, we've lost touch with it in the warmth and light of our own homes. But those wonders are still there. So if you've been given a telescope for Christmas or just curious about where to begin, this is the program for you.
We're going to go right back to basics, because whether you're 8 or 80, it's never too late to start stargazing.
What's that up there? But is that a star above me? There. Oh yeah. Just there. A star!
Especially if you follow some of our tips and tricks to get you going.
Do you do it via the constellations?
No. Constellations are a disaster.
Chris will be discovering what to look for when buying a pair of stargazing binoculars, whilst Maggie takes a trip down memory lane and talks telescope basics.
Dangerous for both you and the telescope.
That's right.
And I get the real treat, showing you how to get to know the vastness of the night sky with nothing more than just your eyes. Welcome to the Sky at Night.
As the sun goes down every evening, a new world opens up. One by one, hundreds of tiny pinpricks of light appear. Tonight, we're going to show you how to journey into this world and how even a complete beginner can learn to explore the wonders of the night sky. To start that journey, I'm joining a stargazing group organised by professional outreach astronomer and lecturer Charlie Barkley.
Wow, Charlie, thank you so much for letting me join your group tonight. And hello, group.
Hello.
Look at the sky. It's lovely and clear.
So lucky.
Yeah, very lucky indeed. So we've started quite early and there's still twilight down there. Why do you start so early?
I always recommend that the best time to do astronomy is at sunset, because as the sun goes down and the scattered light from the sun diminishes, objects come out in order of brightness.
A star there.
I don't think so.
A star! But is that a star above me? There. Oh yeah. Just there.
Oh, well done. Yes, it is. Yeah, well done. What you'll find is that the order of seeing things goes with age, because people's eyesight sadly gets worse, and I always find that the young observers tend to see things quickly.
What's that up there? It's like a really dim light.
That could just be Saturn, or it's either Saturn or a bright star.
Planets are often among the first things to appear in the sky after sunset. So how do you know if you've seen a star or a planet? Fortunately, there is an easy way to tell.
How do you know the difference between a planet and a star? Stars twinkle and planets don't. So if you see a bright light and it's not twinkling, that's a planet. But if you see it twinkling, then that's a star.
So why does the light from a star shimmer through the atmosphere?
Really good question. Stars are so far away they're just points, and they're affected by all the shimmer. Planets are disks, and therefore their light goes through lots of different bits of the atmosphere.
The other difference between planets and stars is that the planets move around the sky. They gradually change position from one night to another. Their name even means wandering star in Greek. Knowing a bit about them and how they move can help identify them and tell us which planets we'll be able to see on any given night.
So in true Sky at Night fashion, we've created a model of the solar system. Now I must stress that this is not to scale. So we've got the sun here, then we've got the planets Mercury, Venus, Earth and Mars. Those are the 4 rocky planets in our solar system. And then we move out to the gaseous planets. We've got the gas giants, Jupiter and Saturn, ending with the ice giants, Uranus and Neptune. All the planets you can see here are visible to the naked eye, with the exception of the outer planet, Neptune. Uranus is just about visible. It's right on the threshold of naked eye visibility, but you need a really dark sky and good eyesight to be able to pick it out.
All of the planets orbit in the same general plane, but at different rates.
Now this alignment we've got here is actually quite unusual. In reality, all the planets will be scattered around their orbits in different positions.
And it is where they are in their orbits relative to the Earth that determines whether they are in our daylight sky or nighttime sky, and so whether we can see them at night.
Now when a planet is in the opposite part of the sky to the Sun, that's termed opposition, and to the naked eye that's when these planets here tend to appear at their brightest in the sky for us. Let's take Mars for example. When Mars is at opposition, it's actually relatively close to the Earth. But if, for example, it was on the other side of its orbit, in this position, it lines up more or less with the Sun. It's very difficult to see and a long, long way away from the Earth.
So if you hear that a planet is at opposition, it's well worth looking out for it. But you'll never hear that Mercury or Venus are at opposition, and there's a good reason for that.
Now the two inner planets, Mercury and Venus, have orbits which are smaller than the Earth's, so they can't appear in the night sky. They always tend to appear in the evening twilight or the morning twilight. And in fact, if you go out after the sun has set and look towards the west and see an intensely bright object sitting in the sky, that is likely to be Venus.
And if you want to find out what planets are visible on any given night, there are a range of apps and websites that can tell you exactly where they will be and when they will be at their brightest. While the planets move around the sky, the stars always appear in the same place relative to each other. Their positions can be used as a map to find your way around the night sky. Throughout history, people have used the patterns that the stars trace in the night sky to tell stories of people and animals, gods and monsters. And that's how the constellations were born.
Some of the oldest constellations are the 12 signs of the zodiac, but others are ancient too, with origins which stretch back to the Babylonians and the Sumerians, several thousand years BC. Over time, they've been added to, and there are now 88 officially recognized constellations, which astronomers worldwide use to talk about the sky and to describe where objects are within it.
But if you're new to the night sky, you don't need to worry about the constellations.
So how do you introduce the stars and the patterns to newcomers? Do you do it via the constellations?
No.
Oh,
Constellations are a disaster.
Right.
Beautiful art, lovely patterns, wonderful stories, of course. But no, I avoid constellations because if you get people up there looking for dogs and bears and dolphins, you know, they're going to be pretty disappointed. And so what I tend to do with people is to really find their own patterns and to find the patterns through seeing the brighter stars. They can then learn those patterns and then find their own way around the sky.
This is a great way for any beginner. Just start by making your own patterns up as a way of familiarizing yourself with the night sky. And that's what we asked our group to do. And the reason we've all got red torches is because red light affects night vision far less than any other colour. So a red torch helps you draw while you can still see the stars.
So imaginations are running wild now with all the patterns and stars you can see up there. But of course you've got to link the drawings to what you can actually see up there. Have you got any techniques for doing that?
What I would do is I would make sure everyone has a reference star. So let's take the very bright star over there and then use your hand to mark distances. Now everyone has the same sort of proportion, so if you hold your hand out at arm's length,
yes,
then the spread of your hand, that's about 15 to 20 degrees.
Yes.
And you can then start saying, okay, go 20 degrees and then use the clock. So if we start at that very bright star, go 20 degrees at about 2 o'clock.
Oh, okay.
Okay, and there we go, and we hit that star
It's a very good way of doing it because that's actually teaching star hopping as well.
It's all about learning a few starting points.
Yes.
And you learn a few bright stars, and then once you've got those, exactly, you can find a way. How are we doing, guys? I've got some busy drawers. Oh, you got the W. Well done. And
Once you've had fun looking for your own patterns, you can start to identify recognized patterns or asterisms. This is the W in the constellation of Cassiopeia, and the outline of Orion the Hunter. And when you've got to know a few asterisms, you'll start to understand where some of the constellations are. A great step in your astronomical journey. Take a look at our website, where you'll find a simple guide for finding some of the constellations. Each one you learn will help you find the next. So far, we've been considering what you can see with the naked eye. But as you get to know the night sky, you might want to take a closer look at some of the things you can see. And a great next step is to get yourself some binoculars. Chris picked up his and went on a mission.
The evening was chilly and overcast, the kind to make normal people scurry indoors, seduced by the welcoming lights of home. Not me. I've always liked the dark, and even city nights have stars and the occasional planet to find. And of course, the moon. The night sky has become an old friend, and stargazing at the end of the day is my escape. On that particular night, I was on a mission, and I had a companion, Jo Richardson, who spends her days and her nights talking about and enthusing about that old rascal, the night sky. I knew a place where I could get above the walls and the buildings of this old, damp city, and that's where Jo and I were headed. We were going to take a closer look at our next-door neighbour, the moon. Right, well that's quite enough of that, I reckon.
Absolutely, let's get rid of this.
So Jo, why are we on a rooftop in the middle of Oxford?
In order to look at the moon using a pair of binoculars in a light polluted sky.
And we only need these simple binoculars to do this. What are we looking for when we choose a pair of binoculars for astronomy?
So binoculars that we use in astronomy need to have several features. They need to have these flared ends.
Because you want it to collect as much light as possible.
Yes, you do. And looking at the moon using a pair of binoculars is super cool, because if you have a look, Chris,
Yep.
you can see lots and lots of features on the surface of the moon, including craters and dark areas and light areas.
I am always amazed that even with something, this is just a small pair of binoculars, you can see an incredible amount of detail. Like you can see, for example, the contrast between the dark and the light areas is really obvious.
Those blackened areas are literally what we call mare, which is the Latin word for seas.
Right, yeah.
But they're not full of water. You might think sea means water, but actually it means volcanic lava, which has been formed for billions of years and dried on the surface.
So we talked a bit about what to look for with binoculars. You said we want something that will collect a lot of light. So the thing to look for are these numbers. So mine say 7 times 50 or 7 by 50. The first number is the magnification. Jo's binoculars made things appear 10 times closer. The second number is the diameter of the lenses at the end. The bigger this number, the more light the binoculars collect. 7 by 50s or 10 by 50s are really good binoculars for astronomy. Great magnification, but they're still light enough to hold comfortably. So one of the nice things about looking at the moon, of course, is that it changes from night to night.
On a night like tonight, we are currently in a waxing gibbous moon, which gives us a quite a large surface to look at. It's not an ideal moon to look at. We would be normally thinking about looking at first or last quarter or crescent moons.
So why is that? Why is the moon sometimes better?
Because that gives you a better definition between light and shadow, particularly on the terminator line, which is the bit where we go from light to dark. I can actually show you just how this happens.
Okay.
So if I give you this piece of rock and you be the moon.
Okay, this is the moon, very convincing moon.
It's
yes,
a very convincing moon.
Yeah.
And I'm going to be the sun.
Okay.
And here I am, the sun, this is giving us what we would see as a full moon.
Okay,
so the
the
sun
light's
is
coming straight
directly
down.
shining on the surface of the moon. And it appears quite flat.
Yep.
But if when we move the angle of the sunlight.
So this is because the moon is moving, but we'll
yeah.
keep the moon the same here, yeah.
So if you can see, you suddenly then get this lovely definition of shadow and light, certainly on the right-hand side of that particular piece of rock.
So you see more when the sun's at a low angle?
You do, yeah. If you look along the terminator line, you can see lots and lots of different features, craters, sometimes you can see mountain ranges with really high-powered binoculars, but incredible detail.
Well, that's amazing, but it's not just the moon that you can look at through binoculars.
Absolutely, we can look at lots of other celestial objects. Planets are superb to look at through binoculars, particularly planets such as Saturn. Quite often you can see the rings, and obviously if you can also look at Jupiter, you can often see the 4 Galilean moons.
So how much would you be looking to spend if you're buying a decent pair of binoculars?
Well, a decent pair of binoculars is about £70, but you can actually get binoculars a lot cheaper than that. You just need to look in the right places, really.
You see lots of them these days in second-hand shops and things like that. If I was going to go hunting for a bargain, what should I be doing?
Always make sure that you test by looking at an object through the binoculars. I've got a pair here. Please have a look, because you'll probably find a double moon. Try and focus, as I say, the
Oh yes, no, it is a double.
Yeah, it's a double
it's
moon.
quite pretty, to be fair.
So those particular binoculars were dropped by a bunch of Boy Scouts who I was working with
and so that's not fixable?
It can be, but it's probably cheaper to buy a new pair.
Well, Joe, you've certainly inspired me to get my old binoculars out, which is wonderful. Thank you very much.
You're more than welcome, Chris.
Back with our stargazing group, we'd been out for a few hours and were beginning to discover how the sky changes during the course of the night.
Stay out for about an hour or so and you'll see that the moon will have moved slightly across the sky. But it's not the only thing the stars move too. In fact, they appear to rotate around a fixed point in the sky, rising in the east and setting in the west. Now that fixed point in the sky is quite important to us, isn't it?
Really important. It shows us due north, so Polaris is the fixed point of the stars. All the other stars move in anti-clockwise circles around Polaris.
And that's because it sits in the sky above where the Earth's North Pole is.
It's on the axis of the Earth's rotation.
There is a very easy way to find Polaris. It involves probably the most easily recognized asterism, the saucepan or plough. If you draw a line between the two stars at the right-hand edge of the pan and extend it upwards, the first bright star you come to is Polaris.
Oh, I see it.
You got it?
It's so
Well
big.
done.
Yeah, it is.
And then when you point to Polaris, and we've found it already, you point up there, you're pointing due north, and the angle of your arm between that and the horizon is your latitude on Earth. So not only can you find north, you can find your latitude on Earth.
It's a really useful piece of information.
But during the night, of course, the pattern moves itself round. And one rather nice thing is that if you find the saucepan, you can actually tell the time, because it takes basically 6 hours to go from as it is now. In 3 hours' time, it'll be up there. Yes. 6 hours' time up there. So you can actually use that as a clock. Yes.
Brilliant. The plough is such a useful asterism, partly because it is always visible in the night sky from the UK. But which stars and asterisms we can see varies throughout the year, because the Earth travels around the Sun.
So in this model here, I'm representing the Earth and there is the Sun. So any stars which are in that direction there, I can't see because the Sun is too bright and in the way. Any stars which are in this direction, in the opposite direction to the Sun, I can see really well because they're in my night sky. But if I move 3 months on around the orbit into this position here, the stars which were invisible to me over there are now beginning to appear, and the stars in that direction down there are now invisible to me because the Sun is in the way again. If I move another 3 months on, so I'm 6 months after I started now, the stars which I originally had in my night sky, I can't see now because the sun is in the way. But the stars which were invisible to me are now in my night sky. So over the course of a complete orbit, in other words a year, you get to see different constellations and stars in the night sky.
The night sky is fantastic to look at with the naked eye, and we've seen how binoculars can show you more. But as your curiosity grows, you might start thinking about telescopes. So here's our guide to the two main types, how they work, and what you should think about before buying one.
For most of my professional career, I've been building instrumentation for large telescopes. But it all began for me when I was just a child. I grew up in wonderful but light-polluted London, and inspired by Patrick Moore, I wanted to discover everything that was out there. So I joined an astronomy club. But it wasn't any ordinary astronomy club, because this club didn't just use telescopes, they also made them. And tonight, I've come back to visit.
The club is still run by my old teacher, Terry Pearce. He had agreed to give me an expert explainer on how telescopes work.
Maggie.
Oh, hi, Terry.
Oh, it's wonderful to see you.
It's lovely to see you. So I was a bit distracted by this.
Well, yes,
It's been years.
I know, many years.
Telescopes need to do two things: gather and then focus light. The one I had spotted as I came in was Terry's demonstration model of what is called a reflecting telescope.
So I always think of a telescope as a light gathering bucket.
Yes.
The bigger your bucket, the more light you can gather. So let's imagine we've got a star up there, and the light comes down and hits our main mirror.
Yes.
Okay.
Our primary, yes.
Oh, yeah, our
Yeah,
primary mirror. There's only a very slight curve on this
The
one.
merest switch of a curve to bend the light back up to the top to make the picture. Yes.
Okay.
So it's back up the tube, and of course it would go straight out the tube and back up and focus way above the tube. So we put our little baby secondary mirror in the way, puts the light out the side, and then we can put our magnifying eyepieces in to that holder.
Yeah.
So a reflecting telescope uses a mirror to focus the light it gathers. But the mirror's surface needs maintenance. That means it's not always ideal for a beginner. The other main type of telescope is a refracting telescope, and it uses lenses to focus the light.
You see, now this looks more familiar. This looks like what I bought as a child. Now, the difference with a refractor is that the light actually passes through the lens.
Straight through the lens and makes the picture in the same way that our reflector does, but the no mirrors in the back at the moment in this one, and you just focus up immediately behind. So it's easy for you. You point the telescope where you want to look.
The downside to refractors is that you need larger lenses if you want to get more light. And lenses are expensive.
Oh, thanks so much, Terry. It's been wonderful. It's been a trip down memory lane for me.
Yes, Maggie, thank
but it's
you.
lovely to see that this project's still going strong.
Yes,
So congratulations.
Thank you very much.
It had been great to see Terry, but I knew that another old friend, Simon Lang, had set up a telescope outside to explain a few other things you should consider when selecting the right telescope for you.
Hello, Simon.
Hello, Maggie.
Lovely to see you again.
I was going to say, it's been a few years, hasn't it?
But we were making telescopes together a number of years ago.
That's right.
Now, it's not the best of nights, but you're here with a sort of, I think this is an 80mm refracting telescope.
It is indeed, yes.
Simon's 80mm telescope gave a relatively low magnification. But low magnification means a large field of view, and that's great for beginners.
This is a good starting telescope, would you say?
It's ideal. When you're first starting out in astronomy, it's very important to learn your way around the night sky, and having a small telescope to start with actually helps you to hone your eye, learning the constellations, seeing the movements of the planets over a period of time. But it will still get you close enough that you can actually home in on what you want to look at.
Now, as I said, it's not the best of nights. This is quite a small telescope, a sort of
It
good
is,
starter
yes,
telescope.
yes.
But you have these fairly large weights here as well.
Yes, this one's a little bit large for this particular telescope, but it's very important that you try and balance your mounting as carefully as possible, because if you've got too much weight on one side or the other, when you release the clutch that allows you to move the telescope, it can suddenly swing round.
Dangerous for both you and the telescope.
That's right. So the first thing you do with any telescope system is you make sure that the telescope and the mounting are well balanced, and that way you get a nice smooth movement in both axes.
And so we've got the weight, but we've also got what seems to be a fairly substantial mount for it as well.
Well, that's actually very critical for when you're looking through any telescope. You don't want wobble. And so you want the most substantial mount you can possibly get for whatever aperture telescope you've got.
So one of the challenges is that the Earth is rotating.
Yes.
And that makes it appear that objects in the night sky are moving across the sky.
That's right.
Now, that means that they can quite easily go out of your field of view.
You want to be able to track them in one way or another. Most German equatorial mounts like this have got these slow motion controls, and as you can see, as I turn them, you can see the telescope is slowly moving. Now, for a while that will last fine, but make sure that your mounting can take motors.
Ah, yes.
Because if you can then fit a motor later on, it allows you to have the telescope track the star across the sky.
So start off with sort of a mount that is you can upgrade later.
Yes. Try and future-proof any purchase that you make.
This is a really important tip. Make sure you invest in a good mount. That way you can upgrade your kit as your interest grows.
So we've discussed sort of various elements of the telescopes, but how do you go about choosing the telescope that's right for you?
I would suggest you try a few examples before you actually go out and buy your own.
So try before you buy?
Yes, absolutely. And the best way to do that is try and track down your local astronomical society, get involved in their meetings. Every now and again you'll hear of star parties in various parts of the country, and it's a fantastic opportunity to get out into the countryside and look from dark skies. But the added bonus is you've got lots of enthusiasts and they're only too happy to allow you to have a go at it, and you can discuss with them what the sort of thing is that you're after, and they'll probably be able to give you lots of tips.
Oh, yeah. Even with the cloudy skies, it's been fantastic being here.
It has been very nice to see you again.
Our group had much clearer skies than Maggie, but that also meant that it was cold, so it was time to go. But in our few hours, we'd covered a lot of the basics for getting started in exploring the night sky.
Well, I've had a fantastic time tonight, and I would just really like to say thank you to everybody for coming out here and braving the cold, because it is very chilly, isn't it? Yeah.
Yeah, it is.
So what's been your favourite bit about this evening?
Mine was being able to tell the time with the plough or the saucepan, because I didn't know that it changed its angle. I thought it just stayed the same angle.
Oh, right, okay.
Mine was being able to see Jupiter and Venus. I just liked looking at the constellations.
Have you had a good time?
Yes.
Fantastic. And thank you, Charlie, for letting me join your group, because it's been brilliant.
We've been very lucky. It's been a fun evening.
I hope we've shown you that wherever you are, or whatever your knowledge of the heavens, there's always something to be gained by looking up at the night sky. Now we're off air for a couple of months, but we will be back in April, so until then, good night.
And in that time you can further your heavenly knowledge with the entire series of The Planets, streaming now on iPlayer. Next, a space quandary that has stumped even the most intelligent of scientists until now. How to see a black hole, the universe's greatest mystery.